Not all observations in science are experiments. In fact, there are whole areas where scientists don't and cannot experiment. In astrophysics, for example, you cannot experiment because you're unable to manipulate the relevant objects that you're investigating. You cannot manipulate stars. So instead, you just have to watch what the stars do, what they're doing anyway. And you can't control the background conditions either. So astrophysics is not an experimental science. And in many other scientific areas, we cannot experiment either. Sometimes for the sheer physical impossibility, sometimes for economic, just because it's too expensive, and in many cases also because it is unethical or illegal. So you cannot just manipulate the world in which people live and have rights, and in which manipulation costs a lot of money, in all the kinds of ways that you want to, and sometimes you just have to resort, quite often actually, you have to resort back to just observing what's going on. In those cases, we're talking about observational studies. Observational studies are not experiments. Here's an example from the social sciences, which I think is interesting, because here the hypothesis relates to the relationship between workers' wages that you see here on the left side, and their risk of death in the job. The hypothesis says that there's a certain degree of influence of risking to lose your life on the job, how dangerous your job is, and the level of your income. The problem with this is, the investigation would then go and sort of look at different workers and where their different wages, and look at their different risk of death. The problem with this, of course, is that there are lots of other variables that vary too when you look at different workers, right? So you won't get workers who differ in wage and then only differ in their risk of death. They also differ in their education, in their age, in their gender, in the type of job they do, et cetera, et cetera. And you have to take, and all of these might, at least potentially, be influences on their salaries. So how do you isolate this part here? In an experiment, you basically take all of this as the background variables and you control for it by manipulating the system. Here, you can't do it. In an observational study, you can't control the background variables. You have to deal with them somehow. You have to, and then this is something that then statistics tries to do, by making relatively strong assumptions about whether the influence of these respective variables can be isolated and so on. But it's very different when you are able to experimentally manipulate the background conditions in such a way that they are, for example, that they're the same, or that you're even able to eliminate the influence of some of these factors altogether. So an observational study, the examples that I just showed you, in an observational study, you cannot manipulate, and you cannot achieve any kind of intervention on the target variable through manipulation, consequently, nor can you establish control. There's a special kind of observational study where you might be able to argue that's something that you find control to be established. That's sometimes called a natural experiment. But one should be careful not to simply by the name of it conclude that it is an actual experiment. So the example that I have here is from early epidemiology. There was a cholera epidemic in 19th century London, and there was a doctor who developed a new method of investigation. So he went around and he observed. He just observed who was sick, who was infected, and who wasn't. And he actually located that on a map. This is a map of Soho, and the black dots that you see here are the households where infected people live. And then he looked at these two groups, the infected group and the non-infected group, and he argued that these two groups were basically identical. Identical in terms of the distribution of all kinds of properties. Their age, their gender, their professions, whether they were sick otherwise, and so on. What their income was, or whatever the relevant aspects were. They said we cannot find any difference, except for one. There's one difference that we can find, and we can identify that through this mapping. And that is where they draw their water. So at that time, typically you didn't have indoor plumbing, but instead people would go to wells and pick up water from there that they use for cooking, but also as drinking water. Today we might say, oh, well, that's an obvious thing. Sort of like we know about the germ theory of disease, so therefore we know that diseases are transmitted through water supply, amongst others, and that the fact that the one well drew its water from upstream Thames, upstream from London, versus while the other one drew it from downstream the Thames, meaning all the unfiltered sewage of London was part of what these people were drinking, might today strike us as sort of a real no-go, but at that time people were not aware of how these diseases were transmitted. So it was a real discovery to say, look, the only difference here is where they draw their water supply, and that therefore must be the cause of the disease. Note, however, that the good doctor did not in any way manipulate the system, the neighborhood. He just went about and observed. He was just lucky that he could not find any difference in any of the background variables except for this one, water supply. So therefore, he didn't have the same problem as the one that I showed you here, where people varied in all kinds of other things. So he could argue that against a stable and identical background, the only difference that he could observe was the water supply, and that then had to be the difference maker, the cause of this effect, i.e. The disease. So we can say that natural experiments are a kind of observational study where we cannot perform manipulation and where we cannot intervene on the target variable, but where we can establish, or where we find, rather, the background variables to be controlled, even though this was not achieved through manipulation. Now, contrast that with, for example, a field experiment. In a field experiment, we are often taking the background variables as given. Now, we're not changing the soil, we're not changing the hours of sunlight, we're not changing the watering conditions. The only thing we're changing, which is the intervention, is that we're giving to one part of the field, we're giving fertilizer, and to the other one we aren't. And we're making sure that the background conditions for both of these fields are the same, so that we don't test the fertilizer only on that part of the field that gets a lot of sun, while the other part is in the shade. Right? That would be a bad experiment because we failed to actually establish background control. But in a field experiment, we would take most of the background conditions as given. In a laboratory experiment, to the contrary, here we're constructing even most of the background conditions. So we're massively manipulating the system, we're building things up pretty much from the bottom, and we're determining at what temperature, at what pressure, at what pH value, and what have you, we are performing our intervention. So the difference between the lab and the field would then be that how much we are engaged in influencing the background conditions. Here's another thing that's often called an experiment, a simulation. What we do here is we're programming a computer to perform a certain sequence of steps, and we might use that to represent something. For example, we might represent a landscape, we might represent certain wind movement on it, and then we might represent some kind of pollution that is emitted, and then we observe how the pollution, let's say, distributes in that particular landscape in our simulation. But the important thing here is that we're doing all of this on the representation. If we now, for example, say, well, what if we changed the wind conditions by building a large screen on one side, or by moving the emission source a little bit behind one of these hills or something like that, then we would perform that intervention on the representation, not in the landscape itself. And that makes an important difference. We're manipulating, but we're manipulating only the representation in the computer. We're not manipulating the target itself. And that distinguishes simulations from field or laboratory experiments. I've given you a couple of examples, some of which are experiments and some of which are not. Here's at least a definition that covers all of those cases in order to distinguish them, where I say an experiment is a controlled observation in which the observer manipulates the real variables, those factors that are actually out there that are believed to influence the outcome, both for the purpose of intervention and for the purpose of control.